All right, chapter 2, section 2, infinite limit and limits at infinity, okay? We've already talked about this, so it shouldn't be too much brand new stuff. But what I mean by infinity is it goes up forever, down forever. Those are two infinities. There's positive infinity to the right, there's negative infinity to the left. You've already seen this when you have a vertical asymptote, it goes up forever or down forever. When you have a horizontal asymptote, goes to the side forever, goes to the other side forever. Remember doing all those? That's what this is going to review. Vertical asymptotes, horizontal asymptotes. So hopefully you remember that from chapter 1. And it's going to talk about how do we know that's going to happen? We can look at it from the left, from the right to see when it's going to happen. Okay? So I'm going to highlight the more important stuff. But bottom line is, it's when it goes to infinity. If I look at the function f of x equals 1 over x minus 1. Let's put that in our calculator. Let's go to our calculator. And before even doing it, we go to our calculator. We type in 1 divided by parenthesis x minus 1. We're going to keep it the same window, negative 5 to 5, counting by ones. Negative 5 to 5, counting by ones. Window, negative 5 to 5, counting by ones. Negative 5 to 5, counting by ones. We look at this, and we notice something, okay? By the graph, we notice that at 1, it goes to negative infinity on the left side, and it goes to positive infinity on the right side. And we already know, what do we have at 1? What's it called? A vertical asymptote, okay? And because we all did chapter 1, looking at the function, why is there a vertical asymptote at 1? Looking at the denominator, what makes that 0? 1. So bottom line, something's going on at 1. We know it's a vertical asymptote. Are we okay? We can use limits to know that's coming. So there's the graph of f of x equals 1 over x minus 1. We know something's going on at 1. But here's what we're talking about now. If we type in 1.1, 1.01, 1.001, 1.001, 1, as we get closer and closer to 1, look at this other side. Is it getting very big or very small? Very big. Very big. As we're getting closer and closer to 1, it's getting very big. It's actually going to what? What's a very big number? Or approaches infinity. Is this going to positive infinity or negative infinity? Positive infinity. So we can see as we're getting closer and closer to 1, from the right, it's going to positive infinity. So if I back up, from the right, I can estimate it's going to positive infinity. Okay? From the left, 0.9, 0.99, it's going to what? Negative infinity. That's limits. As it comes from the left, it comes from the right. We can actually estimate that from the left, it's going to negative infinity. From the right, it's going to positive infinity. So, if from the left and from the right are not the same number, does the limit exist at 1? No, does not exist at 1. Because from the right and from the left, they're different. That's how it's connected. Now, the symbols for this is as the limit of x approaches 1 from the right, it goes to positive infinity. It goes up forever. The limit as it goes from the left goes to negative infinity. Are they going the same place, same directions, two totally different things? And they're not going to a number. They're going to infinity, so it does not exist. The limit does not exist. Okay? The infinity symbol is used to describe the manner in which these limits fail to exist. Such limits are called infinite limits. The symbol for infinity is used to describe positive growth without bound, and the symbol negative infinity is used to describe negative growth without bound. So if we have a vertical line as a vertical asymptote, if it's coming from the left and right and it approaches infinity, it could be both positive, both going to positive infinity, both going to negative infinity, or reversed. And if the function is a polynomial, then it will approach. A polynomial function has no vertical asymptotes. A vertical asymptote for a rational function, you're only at a zero of the denominator, which we talked about before, how to do a vertical asymptote. Okay? So here's what I want you to do. Here's your function, x squared plus x minus 2 over x squared minus 1. I want you to tell me, is there a vertical asymptote? And I'm going to add something. Is there a horizontal asymptote? I'm going to add. Is there a vertical? And is there a horizontal? So do you remember chapter 1 is what I'm saying. And I'm going to ask you to also check if you're right, graph it. Use your calculator to graph it. But we're going back to vertical and horizontal asymptotes. We can keep it the same window, negative 5 and 5, negative 5 and 5. Okay, so a couple things. You remember that if you want to find a vertical asymptote, it's where the denominator is 0. And then you probably said, oh, I better factor this. And if you factor the denominator, you get x minus 1 and you get x plus 1. Are you with me? So if you do that, what makes the denominator 0? Negative 1 and 1. So if you did that, you got x equals negative 1 and x equals 1, and you may be telling me that there's 2 vertical asymptotes. But then, some of you may have went ahead and graphed it. I don't see 2 vertical asymptotes. I only see 1. So in order to figure out a vertical asymptote, what should you do first to be careful? Simplify. Can you factor the numerator? What does that become? What is it? Oh, and then what ends up happening? So first you should simplify Then you figure out we only have one vertical asymptote. Okay? So be careful with that. Simplify first, and you realize there's only one vertical asymptote. So yes, you have a vertical asymptote, and it's at x equals -1. Then, let's see who has a good memory. Do we have a horizontal asymptote? Why? So to figure out a horizontal, the degree of the numerator is 2, the degree of the denominator is 2. When they match, listen carefully, do you have a horizontal asymptote? Yes. And where is it? The leading coefficients, 1 over 1. And what's 1 divided by 1? We have a horizontal asymptote at y equals 1. But again, the reason why we spend so much time graphing and all that stuff is when you're done, you can check everything. If I look at my calculator, I only have one vertical asymptote, and that's at x equals -1. And I have a horizontal asymptote at y equals 1. You can check everything. Okay? You can check everything. But that's actually review. That's review. So why are we talking about it in this section? Well, we realize that if you plug in 1, then you get 0 over 0, and it does not apply. 0 and 1 does not apply. But we want to figure out what's going on at 1. So what I'd like you to do is if we want to find the limit as x approaches 1, because we know there's a vertical at -1, we know there's a horizontal at 1, but what's going on at 1? What's going on at 1? If you take 1, plug it into the top, 1, plug it into the bottom, what do you get? You get 0 over 0. Does that mean we stop there, or do we explore further? Explore further, okay? So if we explore further, like we just did, factor, simplify first, now plug in 1. 1 plus 2 is 3. 1 plus 1 is 2. What do we get? 3 over 2. So be careful, not only for vertical asymptotes, but also for limits, that you simplify first. Getting a 0 over 0 means you're not done, means you have to explore further. And then we have the calculator, so we can do second trace, number 1 for value. I can go look at 1. If I go look at 1, if you look at 1, it's 3 over 2. From the left, it's 3 over 2. From the right, it's 3 over 2. The answer is 3 over 2. Okay? So we have all these tools to back up why it works and to check. Okay? So limits at infinity and horizontal asymptotes are used to describe the behavior of functions as x assumes arbitrarily large positive or arbitrarily large negative values. We use infinity symbol, negative infinity symbol, and we say as x approaches infinity or as x approaches negative infinity. Okay? Again, these are some, we're going to do them, right? But these are some properties to know. If p is a positive real number and k is a real number except 0, then the limit as x approaches negative infinity of k over x to the p gives you 0. The limit as x approaches positive infinity of k over x to the p gives you 0. Okay? And again, a way to figure this out is if k is just a number, if you plug in a really large number, k divided by a really large number is kind of like going closer to 0, going to 0. If you have the limit as x approaches negative infinity kxp, that will go to infinity or negative infinity. And if you have a limit as x approaches infinity kxp, will either go to infinity or negative infinity. Bottom line, we're going to do these. These are just some rules. So let's look at this one. Let p to the x equals 5x cubed minus 2x squared minus 3x plus 6. Find the limit as x approaches infinity and as x approaches negative infinity. So what are we going to do here? One thing we can do, I'm going to write this out for you, is if we had p to the x equals 5x cubed minus 2x squared minus 3x plus 6. If I factor out a 5x cubed, that will leave me with 1 minus 2 over 5x minus 3 over 5x squared plus 6 over 5x cubed. Now you're trying to figure out why am I doing that? I'll get there in a second. If we focus on this part only, and I take the limit as x approaches infinity of just this one part, going back to that previous page, what they were trying to say is this. If we're going the limit as x approaches infinity, infinity is a really large number, okay? If I plug in infinity for all these x's, what that previous slide was telling us, a number over infinity is essentially 0. Any number over a really large number, okay? 1 over a million, 1 over a billion, 1 over a trillion, it's essentially 0. So this is telling me the limit as x approaches 0, all of these are going to become what? 0. So all of this just ends up with 1. That's what the previous slide was trying to tell you. Now, if all of that, 0, 0, 0, 1 minus 0, it just ends up being 1, that means we're really just left with that lead coefficient. We're left with that lead coefficient. And if you plug infinity in for x cubed, infinity cubed is even larger. A huge number times 5, it really just ends up being infinity. And again, you could have just plugged infinity into the original and you'd see it's huge, which means it's going to be infinity anyways. But they're trying to focus on the lead coefficient here. The lead coefficient. Everything else just turns to 0 with that 1. So what this all ends up saying is the limit as x approaches infinity of 5x cubed ends up being infinity. And if I take the limit as x approaches negative infinity, what do you think would happen if I plug in negative infinity? Negative infinity cubed would be a positive or negative number. Negative times negative times negative. This would end up being negative infinity. Now, you're trying to come up with what the heck is this all about? To be honest, here's what it's all about. What you're able to determine, which is not going to be amazing to you, but is interesting. So if I go to infinity, it goes up to infinity. If I go to negative infinity, it goes to negative infinity. What is this really telling me? And again, it's not going to be exciting, so don't expect some dramatic thing. Here's a graph of the function. And what is it telling me? Is that as we go to negative infinity, where is this going? Down to negative infinity. As we go to positive infinity, where is this going? All it's telling me is how the ends behave. This is a way to tell me that this side, as we go to negative infinity, is going down to negative infinity. This way, it's going to positive infinity. So I can look at that leading coefficient and take the limit, and that will tell me how the ends behave. Not groundbreaking. It's not going to change your life. I understand. But that's the point, what they're trying to get to. Okay, so basically, if we look at the leading coefficient and plug in, as we look at negative infinity and positive infinity, it will tell me how the ends behave. It will tell me how the ends behave. By looking at the leading coefficient and looking at negative infinity and positive infinity, it will tell me how the ends behave. Describes the end behavior. As we go to the right and as we go to the left. Okay? So looking at this one, same idea. And this is also cubed. If you take that leading coefficient, plug in infinity. If I take that lead coefficient, plug in infinity, infinity cubed would be a really large number, positive or negative? It will go to positive infinity on the right. If I plug in negative infinity, negative times negative times negative will give me a negative. It will go to negative infinity on the left. So basically, taking the limit will tell me how the ends behave. This is going about horizontal asymptotes. Remember horizontal asymptotes one more time. If the degree of the numerator is lower than the degree of the denominator, yes, we have a horizontal asymptote at y equals 0. If the degree of the numerator is equal to the degree of the denominator, then it's the leading coefficients, numerator over denominator. But if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. That's reminding you about horizontal asymptotes, which is a review for you. So for this one, see if you remember, are there any horizontal asymptotes? So if I had f of x equals 3x to the 4 minus 5x squared plus 2 over 4x cubed plus 2x plus 7, will there be a horizontal asymptote, yes or no? No. Why? The degree of the numerator is larger than the degree of the denominator. No horizontal asymptotes. This is verifying a living thing. Okay, what about this one? We'll do it out loud. F of x equals 5x cubed minus 2x squared plus 2 over 4x to the 4 plus 7x plus 3. Will there be a horizontal asymptote? Yes. Where will it be? You have to give me an equation. Y equals 0. So yes, there'll be a horizontal asymptote. The degree of the numerator is lower than the degree of the denominator, 3 over 4. So yes, we have one at 0. And again, if you look at it in terms of going to infinity, if we go to positive infinity, this would end up being 0, plug in a really large number. Negative infinity would go to 0, that's leading us to 0. We know how to do it using the formula. And then the last one, f of x equals 7x cubed minus 10x squared plus 4 over 3x cubed plus 9x minus 11. Will there be a horizontal asymptote? Yes. Where will it be? 7 over 3. If you notice, if you look at it going to infinity, if you look at the leading coefficients, infinity over infinity, you're left with a 7 over 3. Negative infinity, same thing. You're left with a 7 over 3. It's just another way of looking at it. You get 7 over 3. So, last one. A newly released smartphone operating system gives user an update when they download a new app. The % P of users that have installed the new app after T days is given by P of t equals 100t over t squared plus 100. What percentage of users have installed the new app after 15 days, 25 days, and what happens as you go to infinity? So bottom line, I want you to plug this into y equals, go to the table feature, see what happens in 15 and 25 days, and then what happens as we go to infinity? What happens as we go to infinity? See if you have any asymptotes. See if you have any asymptotes. You can just use x, yeah, and the calculate these products. But make sure that the bottom is in parentheses. Make sure that the bottom is in parentheses. And make sure your table is set up. Make sure it's past. I saw that. Second window. It should be past. Okay, so again, let's double check little things like are we typing it incorrectly. When I go to y equals, it's 100 x squared divided by parenthesis x squared plus 100. Remember, your table should be set. When you hit second window, it should be ask auto. Second window should be ask auto. So when I go to the table and plug in 15 and 25, 15 gives us 69.23%. 25 gives us 86.21%, which translates to after 15 days, 69% of people have done the update. After 25 days, 86% of people have done the update. Now the question is, what happens if I go out to infinity? Not 15 days or 25 days, infinity, what happens? Well, that means I'm going to start thinking about asymptotes. Do I have a vertical asymptote? Look at the denominator. Is there any number that would make the denominator 0? Can I factor the bottom? No, be careful. It's not t squared minus 100. That I can factor. T squared plus 100, you can't factor. So do I have a vertical asymptote? Nope. Do I have a horizontal asymptote when the degree is 2 and the denominator degree is 2 and they match? What's going to be my asymptote? 100 over 1, which means 100%. So if we waited forever, will everybody do their update? Yes, 100% of people will do the update. So at 15, 69.2%, 25, 86.2%. And then to figure out infinity, we realize that there is a horizontal asymptote at 100 over 1, which gives us 100%. And that ends 2.2. Okay?